numerical person, they're in calculus.
Okay, let's just talk through this one before we get to the fundamental theorem of calculus. Okay, the integral from 0 to 2. Okay, this is nice because we can see all of our boxes, right?
Yeah.
Okay, the area from 0 to 2 would be how much?
2. 2 plus 2, 4.
1, 2, 3. These two make 4?
Yeah.
Okay. How about from 0 to 5?
25.
Okay. This we determined was 4, right?
Yeah.
5, 6, 7. And this is a 3 by 2 triangle.
So there's 3. So that's 4, 3, 7, 10.
Oh no.
Fun.
It's all the little lights off too.
Okay, I guess I can't write on it. It's 10, right? Yeah. From 5 to 7. -3.
Hey.
So if we talk about 0 to 7, it would be what?
7.
It would be 7, right? Because from 3 to 5 and 5 to 7, those two would cancel. They have the same areas, but one's positive, one's negative. Okay? All right. Well, okay. So today is fun day number 1.
Is it fun day number 1 or is it fun day number 1?
Fun.
Is fun some kind of like...
We are going to talk about the fundamental theorem of calculus. Fundamental theorem of calculus. Okay?
Can I have my money back if I did that?
Nope. If a function is continuous on a to b, and f is the antiderivative of little f, then this is what happens. Okay. Now I'm going to see how the heck can I... I'm just trying to see if I can actually write on this here. Okay, here's my integral from a to b of f of x. What does big F stand for? The antiderivative. Okay, so we have an integral. We're going to take the antiderivative and evaluate it over our interval, which really just means, oh gosh, I hate PowerPoint. This is why I don't use them.
What do you use?
Smart notebook.
What is not like this one?
See? Can you click on it?
Well, I can do the laser pointer.
Yeah.
F.
I thought F of X. Got it.
Okay, it's F of B
Oh, that's fine.
minus F of A, for those of you who are at home. All right?
Yeah, but-
That's their fault. They should have been here.
So basically, what this is saying is you can take the antiderivative, okay, and then since we have an integral, we're going to plug in A minus plug in B minus plug in A.
So that red thing is what I equals?
Yeah. Yeah. Now, when we took the antiderivatives, I yelled at you and said, don't forget to put,
Plus C.
do you see a plus C here?
No.
No, you don't see a plus C. So, why? You see me hitting it, right?
People at home don't.
Okay. So why am am I not using the C? Okay, so I'm going to talk about this second part first, okay? We don't need to include the constant of integration. Why? Well, if we have the integral from a to b of little f of x dx, okay? Well, when we take the antiderivative, right, we used to write, well, with an indefinite integral, we would write the antiderivative plus c.
Oh, because it's on a specific range already?
Well, since we're on an interval, we would plug in b minus plug in a,
Oh, these would cancel.
and the c's cancel. So since we're on a specific interval, the constants don't matter.
Okay,
Okay.
that makes sense.
So, why does this work? Basically.
I'm really happy that we don't have to do this one.
You ready?
Alright.
Okay. Now, I'm going to go through a proof. The notation is going to be awful. You're probably not going to like it, but we need to understand why a Riemann sum is giving us the same thing as evaluating an interval. Okay? We understand that our Riemann sum is summing up a bunch of rectangles, right?
Yeah.
Well, when we took the limit, we had an infinite number of really small rectangles. Okay? So why is this the same thing? Okay? So we are on an interval from A to B, correct?
Yeah.
And we're going to partition it. What does partition mean?
Break into pieces.
Break it up into itty bitty pieces. So I'm going to call it x of 0, which is going to be less than our next x, less than our next x, all the way up until n minus 1 and n. Okay, so it's going to be kind of, we're going to relate this back to the Riemann sums here after a while. Okay, so basically, f of b minus f of a, big F stands for what?
Antiderivative.
Antiderivative. Okay, if you're watching this at home, fast forward. Okay, are you getting what I'm doing here? I'm taking f of b minus f of a, f of b minus f of a for all of our little bitty partitions, right? All the way until f of x of 2 minus f of x of 1 plus f of x of 1 minus f of x of 0. Right, so it's still f of b minus f of a.
Is there a reason it looks very much like the trapezoid thing?
Okay. So I'm going to write this as the sum from 1 to n of f of x minus f of x of y. Right? The bigger one minus the smaller one. We're okay? Mean value theorem. What is the mean value theorem?
I think we had it first semester.
Okay. Great.
Is it where something has to equal 0?
Close. Not 0.
First.
0 is like the specific case. Okay.
There has to be a point between 2 points. Like, there has to be like a point C that lies between.
Oh.
Okay. The derivative at a point C. So the derivative of our antiderivative, right? So the derivative is the same as the
Branch.
derivative is the same thing as
Well, so it's
slope of the tangent. So the derivative at some point has to be the same as the average slope. Okay, the average, not the average slope, the average rate of change,
yeah,
right? The slope
yeah,
between
yeah.
our endpoints. Okay, so slope between our endpoints, f of x of I minus f I minus 1, okay, over x of I minus x of I minus 1. Slope, right?
Yeah.
Yeah.
Derivative the same as the slope. All right, well, let's rewrite some things here. Okay, so off to the side. The derivative of the antiderivative
Isn't it kind of just taking it? Is it just?
is the function. Okay, so we've been writing it as little f, right? Little f's our function, big F is our antiderivative, right? Well, what's another way I can express this that we've been using?
M?
We're gonna call it delta x.
Oh, okay.
Okay, right? It's
Yeah.
clicking now?
Yeah.
Okay, so now I'm going to change this to look like f of c equals this. Right? Okay. Now, I'm going to bring this guy and multiply him over. Okay. Is everyone okay so far? Okay. Well, now what if I want to sum up both sides? Okay. What if I want to take the sum okay? I'm summing up both sides. We get something that looks like this, don't we? We called it f of b minus f of a, right? So we have the sum as I equals 1 to n, bi delta xi equals f of b minus f of a. What happens when we take the limit as n approaches infinity?
You get the Riemann sum.
Okay, now, would I ever ask you to reproduce this? No way, Jose.
I was about to say, what?
But do you see how everything's coming
How
together?
this-
Do you see how everything's coming together? When we take the limit of our Riemann sum here, it's the same thing as evaluating our integral over an interval. Okay? So we don't need, now on the quiz you will need, but after the quiz you will not need to have to do Riemann sums anymore. Okay, Riemann sums are a pain in the butt. You agree? I agree. You like them? Okay. Were they efficient? Not at all. We only did very, very simple equations with them, right? They are not efficient at all. They are not, I mean, some of you enjoy them, but it'd be a pain in the butt to do x to the fourth plus x cubed plus 2x plus 1. You want to do a Riemann sum with that? No. But we are really good at taking antiderivatives. And everything that I just rattled off are power rules. Okay, that would be an easy antiderivative to take. All right? So we have the fundamental theorem of calculus. Okay? Yay! All right. So, bringing it all together. An integral, which we've already talked about this, okay? A definite integral is going to give us a value. That value is going to be the area under the curve to the x-axis between A and B. Okay? These are what we call limits of integration. All right? So you've seen an integral before. You know how to take the integral. But now we have limits of integration that is telling you what interval we are finding the area under the curve for, right? I'm not going to go through all of that. Okay? But see, we had cool arrows going there. Okay? So, finding the area. 0 to 1 of 3x squared plus 2. We are actually going to do this here. Okay? What's the antiderivative of 3x squared?
X cubed.
X cubed. Right? Add a power divided by it. And the antiderivative of 2?
2x.
Okay. So we have x cubed plus 2x is our antiderivative. But instead of saying plus c, we're going to say, all right, we're evaluating that antiderivative from 0 to 1. You are always going to plug in your top limit of integration first, then subtract your lower. All right? So we're going to plug in 1 to get, wish my pens worked. When we plug in 1, we get 1 plus 2. When we plug in 0, we get 0. So 1 plus 2 minus 0 plus 0 is our 3. Yes.
Did you just like freeze the page and then write on it?
It won't show up.
Like you could do it with smartphone and screenshot.
But if I freeze it, you're not going to see what I write.
Like on the
Yeah. Don't worry, I've tried. Okay. What I am going to do is this. We'll see if this will work. Okay. Okay, we're going to do a few examples, and then I'm going to show you how to check with your calculator.
Yeah.
So write this one down.
I have to check, but not this.
You know, is it like the? Do you put it on the outside or do you put it like within four? The limits. Is it like the-
Okay, so we have the integral from 1 to 4 of 3 squared of x dx. So first of all, we have 3 times the antiderivative of x to the 1/2. Okay, x to the 3/2, and then we divide by our power. So 2/3 x to the 3/2. Everyone with us?
Absolutely.
3's cancel.
Yep.
Okay. And we're evaluating this from 1 to 4. I want to see your antiderivative with this slash 1 to 4. Okay, I need to see that. Now, we're going to plug in 4. So we have 2 times 4 to the 3/2 minus, plug in 1. 2 times 1 to the 3/2. What?
Wait, equals 3 times antiderivative.
This is 3 times the antiderivative of square root of x. Okay. What's this? Okay. 3/2 means what as a power?
Cube and then square root.
Okay, what's the square root of 4?
32.
Cubed times 2 minus, well, this is just 1.
Yeah.
Get out your calculators. Are you ready? Your life to change. Do you remember how to take a derivative using your calculator?
No.
Math?
Oh, how many agreeable sharks?
Math 8, yes he did, I know he did. Math 8 is your derivative.
I don't think I'm there.
I'm almost done.
I don't think you did.
Yeah, TJ, so
Well, you don't.
Yeah, I don't think.
You guys don't know how to take a derivative when you're calculating?
No.
I found that out.
I
myself.
taught you.
No.
I found that out
I
myself.
don't think so.
Because when we first, because the first time we learned the formula for derivatives was the first day we went share.
That's right.
And you know,
Oh,
he and Rich
no, that was
and
good one.
then Griebel never taught it to us either. Almost everything we did with Griebel was off calculator.
Yeah.
Okay.
So yeah,
I
that was
didn't
his
know that
first
part.
time. we did that.
Yeah, I didn't.
But it's okay, it looks.
Okay, let's stick with integrals and then we'll come back to taking a derivative on your calculator. Okay.
I've never seen this before.
So what I want you to do is go to math and hit, see this 9 is f in inch? That's a function integral. Okay, so hit math 9. Now, if you have a cool calculator like me, it pops up as this. If you have an 83, this is not how it pops up. Okay? So, how many of you have 83s? Alright, hang tight. Those of you with 84s, what was our integral? We had the integral from 1 to 4.
Yeah.
Here it is. 1, arrow up to 4. In here, you're going to write 3 square root of x. Close your parentheses. Oh, dang it, my calculator's in parametric mode.
We'll do 3
Oh, wait, am
at 14.
There. You should get 14. Right?
Oh, shoot, I put, I just dumb here.
Sorry, my function was my mode was in a different, my calculator was in a different mode. Okay? So, it should be X when you type it in. Now, those of you with 83s, you should have something like this, right?
Yeah.
Okay? So, put in 3 square root of X. Now, when you type it in, you get a square root and then a parentheses. So, you're going to put X and then close the parentheses. Comma, we are integrating with respect to X. Comma, we're beginning at 1, comma, we're ending at 4, close your parentheses. Does it work? 83s, we got it?
Yeah.
Okay, for each example, we are going to do it by hand, check with our calculator. Do it by hand, check with our calculator. All right? Okay. Next example. The integral from 0 to pi over 4 of secant squared dx. Okay? So first of all, what is the antiderivative of secant squared?
Tangent.
Tangent of x. And then we are going to evaluate that from 0 to pi over 4.
I think 30.
I think 32.
25. Everyone was wrong.
Ah.
All right. So then we plug in our upper limit first. What is the tangent? Okay, so tangent of pi over 4 minus the tangent of 0. What is the tangent of pi over 4?
Unit circle thing. 1.
1. Gosh dang it.
Minus the tangent of 0.
0.
Hey, we get it, right?
Okay.
I was always so bad at tangents on the unit circle.
Okay, remember pi over 4, 45 degrees, radical 2 over 2, radical 2 over 2, or it's going to be what? Now, when we go to do this in our calculator, what? Anything we do with trig functions, our mode better be in radians. So make sure you go to mode and make sure it's in radians. I am not. Okay? So then we can do math 9. 1 to pi over 4 Secant squared. How do we put secant squared?
Parentheses 1 over, or 1 over plus whatever it is. Yeah.
What? Cosine? You sure?
Yes.
Uh-oh. I have my elements of integration wrong. It should be 0 to pi over 4.
Oh,
That's,
that will change it.
Yeah. Yes.
So this, I was kind of messing around and I just took an antiderivative of something that was like a function of x, but then I took it with respect to t with parametric functions and it came out with an answer. Like, how do you do that?
We'll have to have a conversation later.
Okay.
Okay.
It's adult When you're a senior next year, let's not hear about it.
Okay. Yes, doesn't matter. All right. My next one, the integral from 0 to 5 of the absolute value of x minus 3, the quantity yes. Do we know how to take the antiderivative of a absolute value?
No, we
We did. Yeah.
No,
No, we don't.
Oh, no, it came out, something else came out as an absolute value.
Okay. Yes.
That's it.
Now, so let's think about what this looks like. So the absolute value of x minus 3 looks like what?
I've really shifted
it's
to the right.
shift to your, yeah.
Like this, right?
Yeah, man.
Okay. Now, we can obviously use geometry to do this, but I would like to use the fundamental theorem of calculus. Okay? So in order to evaluate this integral, we're going to have to think about this as a piecewise function. Great. So this piece is what?
Negative x minus 3.
Right? What is this piece?
X minus 3.
Is everyone okay with Jared's piecewise function?
Yes.
Okay. So if we're going to evaluate this from 0 to 5, we're going to have two integrals. The first is going to go from 0 to where?
3.
We're going to take the integral from 0 to 3 of negative x plus 3 dx. And then we're going to add it to the integral from 3 to 5 of x minus 3 dx. Is everyone okay with all of that?
That's where the FP minus FA comes in.
We just broke this up into two integrals because we have two different functions. Now we'll do it. So now we'll have negative 1/2 x squared plus 3x evaluated from 0 to 3 plus 1/2 x squared minus 3x evaluated from 3 to 5. Okay. Let's do this. We plug in 3 to get negative 1/2 times 9 plus 9.
So negative 9/2 plus 9, which would be negative 27/2. Nine plus 18/2.
So negative 9 plus
Oh, gosh.
18/2
Yeah, sorry.
would be 9/2, wouldn't it? Right?
Yeah.
Okay, you were very excited and
I was
thinking.
just. very
Minus,
excited first.
when we plug in 0, we get,
It'd be negative 1.
it would be positive, right?
Yes.
Because this is negative 9/2 plus 9. Let's plug in 5. 1/2 5 squared minus 3 times 5. So 25 halves minus 15.
Negative
Negative 5 halves. Minus, what do we get when we plug in 3?
negative.
So minus a negative 9 halves. Right? So what do we get?
13. Definitely 13 halves.
7 halves.
13 halves. Right? 9 minus 5 is 4 plus 9. Check with your calculator.
7.5.
Double the, well, actually, check by putting the original in. The absolute value you can find under math if you arrow over 1. Correct? Change it to a fraction. You know how to do that.
I wouldn't do it.
Ooh, great point. What happens?
What? Mine works. Are you
Math?
saying
Dang it. Math? Math? 9. Okay, what is it from where to where? 0 to 5?
Yeah.
Of math? Number, absolute value, x minus 3.
Yep.
Okay, notice what I get.
That.
Your calculator, as cool and fancy as it is approximating. So every once in a while, yes,
Would it be that we're in radians?
no,
Yeah.
nothing to do with it. Because we're not using a trig function. Okay? Every once in a while, you're going to get something that's super duper duper close because your calculator is approximating the area. Most of the time, you'll get a nice number. Okay? Every once in a while, you'll get a very, 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 very close approximation. Okay? So 6.5, is that basically what we got? Okay. So I'm really glad that we did this. Okay, is everyone okay with your calculator sometimes giving you a close answer? Wonderful.
That's such a mixed tool.
Really is.
I'm gonna get you.
All right, this is a fun one. The integral from 0 to pi of cosine of x.
0.
What?
It looks like it would be 0 based on
0
the
to pi?
Antiderivative of cosine. What? What?
Sine.
Wait, yeah, there.
Positive sign, people.
Positive sign, guys, come on.
I need to give you a real quiz.
Not even
Talking about
So we're going to take sine of pi minus sine of 0. What's the sine of pi?
0.
Minus the sine of 0.
Also 0.
It's 0.
Hey.
Let's talk about y. Aaron already said, oh, it's going to be 0.
Yeah.
And I said, why?
Because
And he said,
It looks like on the graph, like it would be.
it's symmetrical, and so it changes it.
Yeah, like in that, yeah.
we have positive, negative area that's the same.
They both half, I think. Crest each other.
What if we went from 0 to 2 pi?
Then it would have been just 1/2 of
No, it'd be 0.
Still would be 0.
Oh, duh, yeah. Duh. Sorry. I'm sorry.
3 pi over 2 would be a different story.
Okay, your homework is on page 284. 3 to 33 by 3s
Oh.
So out of 3, 35 to 39, the odd one. You have a 3-day weekend, which means you have plenty of time to get this assignment done. And I expect you to get your assignment done.
She also doesn't care.
This is math, English.
So,
Who said that the essay was my question?
do. I need to know that.
No.
I'm
Okay.
not gonna lie, the apparent point in that, I think it was when you switch colors, and all of a sudden,